Okay, so my transformation that's listed here, we've got multiply the x coordinate by 3. So it's elevation by a factor of 3 from the y-axis, 2 units in the positive x direction, a 4 in front of the y, so multiply the y coordinate by 4, so it's dilation by a factor of 4 from the x-axis, 6 units down. So if we're just going to, I guess, transform a point, just substitute the point in, t of 4, 5 becomes 3 times 4 plus 2, 4 times 5 minus 6, which is the point 14, 14, I believe. Similarly, for t of negative 1, 2, it becomes, or it follows, that 3, negative 1 by 3 plus 2, 4 times 2 minus 6, negative 1, what's that, 2. So now if we want to apply this transformation of the graph of y equals 2 to the power of x, first thing we want to do, so we know x dash will be equal to 3x plus 2, y dash will be equal to 4y minus 6. Let's rearrange those to get x is equal to x dash minus 2 on 3, y is equal to y dash plus 6 on 4. Remember, we do that because the equation I'm dealing with is y equals 2 to the x, so I need to know what y is and I need to know what x is. Substitute those points in, I'll get the y value, y dash plus 6 on 4 is equal to 2 to the power of the x value, x dash minus 2 on 3. Rearrange slightly, we'll get y is equal to 4 times x minus 2 on 3 minus 6. And we could probably leave it like that. So technically, I guess I put my dashes there because I want the dashes there so I understand that this is my new function, my transform function. But I think that's a good habit for us to get into, but you don't have to have it written there on your final answer. All right, so this example here is just a little, I guess, a little example on almost simultaneous equations. I know the transformation T16 will result in -7, -3. So if I substitute that into my equation, I get the point T16 will equal A times 1 plus H, comma, 6 is Y, 6B plus K, and the point, what's the other point? T negative 2, 3 is equal to negative 2A plus H, comma, 3B plus K. And we know that they're equal to specific points, -7, -3, 11, 12. So now if I just equate my x and y coordinates, so from the first one, I'm going to have a plus h is equal to -7. And I'm going to have 6b plus k equals -3. I'll have -2a plus h equals 11. And 3b plus k equals 12. So I've got two sets of simultaneous equations here. So if I subtract off the first lot to eliminate the h's, I'm going to have, I'll do bottom minus top. -2a minus a is -3a equals 11 minus 7, which is 18. A will equal -6, and if I substitute that into the top one, -6 plus h equals -7. H will equal -1. Same thing, I'm going to do this time top minus bottom. 6b minus 3b is 3b, k minus k is 0, -3 minus 12 is -15. So b will equal -5. And if I put that into the top, I'll get negative 30 plus b equals negative 3. Add 30 to both sides. I'll get k equal to 27. So there's my values. Okay, so we've got a composition of transformations, and really we've spoken about compositions of functions, where we substitute points, substitute a function into a function. Well, we're just going to substitute a transformation into a transformation. So here, I'm going to substitute the T1 transformation into T2. So don't forget that, so if I look at T1, this whole thing, if you like, is the X. This whole thing here is the Y for, I'll put X2, Y2 because that's what I'm substituting into. Okay, so T2 of T1 XY will equal 3 times the X value, which is X plus 3, plus 2, comma, the Y value, which is 2Y minus 3. So if I simplify that, I'll get 3x plus 9 plus 2 is plus 11, 2y minus 3. So that's my net transformation. Similarly, T2 into T1. So T1 of T2 xy will equal T1 is equal to x, which in this case is 3x plus 2 plus 3, and then I'm going to put y minus 3 into it, so I've got 2y there, so it's 2 times y, which is equal to y minus 3. That gives me with a transformation of 3x plus 5, 2y minus 6. Okay, so finding our inverse transformation is not unlike finding our inverse function. Typically, we would say that maybe x dashed y dashed becomes 3x minus 2 negative 5y plus 3. That's how we normally set it up, where x dash y dash represents my new function. Well, if I want to find the inverse function, let's just swap those variables around. xy becomes 3x dashed minus 2 negative 5y dash plus 3. And now let's just rearrange again to get x dash y dash equals 2. So from this we can see x is equal to 3x dash minus 2, y is equal to negative 5y dash plus 3. Rearrange x plus 2 on 3 equals x dashed. Y minus 3 over negative 5 equals y dashed. So now I can write x dash y dash becomes x plus 2 on 3, maybe put the negative sign up the top, 3 minus y on 5. So because this is my transformed function, I'm going to write it as, what's my proper notation? We'll just write it as T inverse of xy equals x plus 2 on 3, 3 minus y on 5. So really, that's the transformation that we apply. If we apply this transformation that we've just done, the inverse, so if I apply this transformation to this transformation, we just end back at xy, which is sort of our function of the inverse, or the inverse of the function kind of concept. All right. So finally, example 13, we've got a function here, negative x squared plus 2x. We want to find the range of that function. So if we just do a quick graph sketch, x minus 2, we know we've got intercept at 0, intercept at 2, it's upside down. So it goes something like that. And I know that the turning point is at 1 something. So if I substitute 1 into that function, I get the point -1 plus 2. And the domain is from 0 to 3. So let's just get rid of those singos. So if I just put some values in, that's clearly the point 0, 0. If I put 3 in here, that's the point 3, -9 plus 6, -3. So we can see the range of this function. The lowest value is -3. They're both square brackets. The highest value is up at the turning point there, which is at 1. So there's the range of the function, -3 to 1. So we've got to state the domain and range of the image function. All right, but we've got to find the rule as well. Find the image of f under the transformation. So x dashed equals 2x, y dash equals -2y plus 3. So I get x is equal to x dashed on 2, y is equal to y dashed minus 3 over -2. Substitute those into my function. I'll get y dash minus 3 over -2 is equal to negative of x squared plus 2 times x on 2. That's right. So I'm going to bring that -2 across. Y dash minus 3 is equal to positive 2 x squared on 4 minus 4 times x on 2. I'll get y dash minus 3 equals x squared on 2 minus 2x plus 3. So what impact does this have on my domain? Well, my domain was originally 0 to 3. And I know that the transformation says 2x. So my new domain is going to become 0 to 6. My range was -3 to 1, and the y value is being multiplied by -2 and 3 added. So that becomes -6 plus 3, which is 9. 1 times -2 times 1 is -2 plus 3, which is 1. So let's get that the right way around though. So that becomes 1 to 9. So to be clear, 1 to 9 is my range and 0 to 6 is my domain.